Hi, grade 6 teachers. Let's have a look at some ways that you can connect computer sciences into your energy unit. So you know that your computer sciences is all about abstraction, computational thinking, design thinking. Students are asked to use block-based coding in grade 6 and to create artifacts using block-based coding, and they're also asked to look at sort of the roles of technology in society, how it has had a role and what that role might be in the future. We know that the computer science organizing idea, all the way from kindergarten through grade 6, has three key concepts, one being computational thinking, another being the design thinking process, and the third being creativity. So, all the way from kindergarten through grade 6, these three common threads tie all of the skills, procedures, knowledge, and understandings together. Let's look at how you can specifically connect some of your computer science into your energy skills and procedures. When we're asking students to conduct investigations, we're asking them to identify things, we are going to be working through some of that computational thinking process, asking students to identify examples of abstractions is one of your computer science skills. So you can draw this into lots of places. For example, here we could talk about understanding how all motion can be categorized into simpler groupings. For example, push and pull are applied force. So looking at all different types of motion and how can things be moved or how can things move, and then understanding that we can abstract that down into a few simple concepts that are the knowledge from energy we are actually working with abstracting, which comes from your computer science. And then we can ask students to work on algorithm design. So in grade 6, they're going to be asked to actually build block-based coding algorithms with proper coding structures, and they may or may not have all of the foundational skills that are required from the kindergarten levels up to grade 6 to build those algorithms. So anytime you ask students to work on or create sets of instructions, you're going to be giving them the foundational skills that are really required to do that block-based coding. So we could ask them to come up with a set of instructions for completing an experiment safely. Here they have a skill in energy that requires them to be able to use materials and tools safely. So we could ask them to come up with a set of instructions that should hopefully mean that they will follow those instructions and therefore meet this energy skill. They're also going to have used some of their computer science skills while they're developing that set of instructions or algorithms. We could also ask them to write that set of instructions for a machine so that a machine could complete this experiment and make that connection into computer coding. If we ask students to create artifacts on a computer, we're going to be meeting our computer science skills and procedures as well. Starting in grade 4, there's language around creating artifacts. We begin with artifacts being anything that students are making, building, or creating, and we're moving into what is actually a computational artifact. Again, a computational artifact doesn't just mean a computer program. While it can be that, it could also be a video presentation or an audio presentation or a slides presentation or a website. If you have students use something like a program like Scratch to build some block-based games or interactive presentations to show you what they know. So if we have them build a Scratch game that demonstrates forces acting on an object during an interaction, they're showing us that they understand this energy concept while also showing us that they understand those computer science concepts. And they're taking that computer science knowledge and they're transferring it into their energy understandings, which we know is where we want them to be with their curriculum so that they have a good solid foundation for that understanding or those skills. And even if you just have them doing other computational artifacts, they're still going to be touching on computer science concepts, definitely bridging some of those gaps from the lower grades where they were doing a lot more specific with just creating instructions and coming up with simple sets of instructions. We can have students through other activities draw in those computer science skills as well. Working into some more of these skills and procedures, these are some pretty black and white concepts. We're looking at temporary and permanent changes, or I've put elasticity and plasticity here on the slide for this presentation, but either of these skills we could be working through pattern abstraction and algorithm design. What defines elasticity? Can you come up with a rule? Could we write an if-then statement that would help anyone understand what elasticity means? And same for plasticity. And if we are differentiating between, two types of change and we're looking at specific attributes, what are we looking at to determine if something is elastic? Well, we're looking at if it goes back to shape when it stretches. Does it matter what kind of material it is? That doesn't matter. That's an attribute that we can put off to the side. We can abstract out that the only thing we need to be concerned with is what happens when I stretch or twist or pull or bend it. Demonstrating and representing an action force. Again, students, this is a very specific concept that you're going to probably do some physical hands-on experiments with, but you have the opportunity to have students show you what they know or to demonstrate further through something like a program like Scratch. So asking students to build a Scratch program that demonstrates this concept is going to show that they understand this concept, and then also allow them to use that visual block-based language to design code that has some relevant structures in it. They're going to use the design thinking process as they're thinking about this project and how they're going to meet their end goals. We're going to be transferring, again, that deep level computer science understanding into our energy unit. These energy skills and procedures we also see in our Earth Systems curriculum. We have the ability, again, to apply abstraction and identify examples of abstraction encountered in daily life as we're talking about different factors that influence how we choose energy resources and the factors that influence the selection of principal energy in Alberta. So we're going to be looking at resources. What are all of our energy resources? And now we want to talk about why we choose the resources we choose in Alberta. And so we're going to immediately only be looking at resources that we have in Alberta. That is an abstraction. As we do that with the students, we talk about that is an abstraction. We explain that to them, and that gives them the opportunity to understand a little further so that they're able to apply abstraction in situations when they need it. Again, you see here we have coming up over and over again my little computers with the Scratch program and the slides presentation. Anytime you ask students to create something with a block-based coding program to show you what they know, you're giving them excellent computer science, excellent opportunities to practice their computer science skills and procedures and really help them get to that transfer level of understanding with them. Examining management of energy resources in various contexts, having discussions, in this case about energy resources and how they're used by individuals or communities. We can do brainstorming. So this is that piece of the design thinking process that students are probably the most familiar with. Always draw back into that is a part of the design process. So come on, start throwing ideas at me. Let's do some brainstorming. We're going to do this piece of the design process today as we move towards, a project that we're going to do to show that we understand this. So even during a discussion, we can be drawing out those pieces of the design process or computational thinking, drawing attention to even just the simplest connections as we're doing it with the class is just going to keep pushing that into the students' minds. The more that they hear it and work with it, the more likely it is that it's going to be cemented deeply in for them, and they're going to get to that transfer level of understanding. And we can work on empathy when we're talking about respecting our environment and respecting our resource use, and we can use algorithms to create some rules around resource use and how we define our resource use. And all of these things are going to connect into those computer science understandings in some way. Asking students to classify and group resources, you've probably seen in some of my other connections videos. Once we are categorizing, grouping, classifying, we are using computational thinking to break things down, look at specific attributes, find those patterns, simplify that out into something, and then potentially move towards, what is that rule? What is that set of instructions, or that one thing that defines that attribute or that grouping that we're looking for? So if we're looking here in this case of types of energy resources that can be used, before processing or after processing, we can talk about, so what's the same about all the ones that need to be processed? And what do you think about these ones in the middle? How we use the energy from water different if we use it before water is processed from what does processing water look like? What's that energy look like? What's the difference? And then, making those connections between, processing is, how we get electricity. In fact, we get electricity from many different energy sources. And while we don't really burn wood to get electricity, but if we burn wood right from the natural, there's certainly heat energy that comes off that. So that's a really simple thing. And so what do you think are the advantages of not processing something, and what are the disadvantages of processing, and maybe what are the advantages of some of these processed ones? And once we're comparing off the processed ones together and looking at specific attributes, do they leave waste behind, or is there pollution? That's an important attribute if we're talking about if this is a good thing for us to use. So breaking down, looking at all those different components, finding patterns based on what it is we're trying to learn is bringing in that computer science and computational thinking. Having students design a device that uses energy, this is an opportunity to work through that design thinking process, have them put some creative thinking skills into what types of energies they could use to possibly make something move. You might give them an activity like we see here, or you could just say you need to design a device that uses an energy resource to move, and figure it out and let them work through that design process and determine what that project's going to be. Test, reiterate, go through those pieces of the design process, and any opportunity you have to have them apply abstraction. Can you simplify this? How can you bring this down to its most simple form and get rid of all of the excess? And you're going to be giving them this computer science skill. Abstraction is a big concept. The more that you can touch on it, the more that you can involve it in the other learnings that you're doing, the more likely that your students are going to have a good, solid understanding of it at the end of their computer sciences. So those are some ways you can connect computer sciences into your energy unit. I hope you enjoyed.